So what happens if we have a partial fraction with the numerator with the same degree as the denominator? So here it's x squared and the denominator is x squared. Well, we have various methods. I'm going to give you various methods. The first and easiest method to remember is that when we have the numerator with a greater or equal degree than the denominator, we just do a long division. So what we need to do is divide one into another. For that, we need to expand the denominator. So the denominator is going to be 2x plus 2x squared minus 1 minus x. So that's 2x squared plus x minus 1. So we need to divide one into the other. So when we divide this, we have a 1 here. So that's 2x squared plus x minus 1. And I always put this bracket so I remember to change all the signs. So that's 0. 5x minus x is 4x. Minus 6 plus minus plus 1 is minus 6 plus 1 minus 5. So that means that 2x squared plus 5x minus 6 divided by 2x minus 1, 1 plus x, can be written as 1 plus 4x minus 5 divided by 2x minus 1, 1 plus x. So we have to do the partial fractions of 4x minus 5 divided by 2x minus 1 times 1 plus x, where we have the degree of the numerators now is lower than the degree of the denominator. So that's easy because that can be expressed as the roots are real and unique. We have a divided by 2x minus 1 plus b divided by 1 plus x. So a times 1 plus x plus b 2x minus 1 has to be equal to 4x minus 5. And now what I do is I introduce the roots. The roots are minus 1 and a half. So if I include minus 1 here, this one goes away. So that means b times two times minus 1 minus b equals minus 4 minus 5. So that means minus 2b minus b equals minus 9 minus 3b equals minus 9. So b equals 3. And if b equals 3, we can now introduce the half in this one, and then this factor goes away, and we have a plus a half of a equals 4 halves minus 5. So 3 halves of a equals 4 halves minus 10 halves. That's minus 6 halves. So a equals minus 6 divided by 3 equals minus 2. So our partial fraction expansion would be, I'm going to put it in red so you can see, our final partial fraction would be 2x squared plus 5x minus 6 divided by 2x minus 1, 1 plus x equals the 1 that we had here, then minus 2 divided by, which is the a, divided by 2x minus 1, and then plus 3 divided by 1 plus x. That's our partial fraction expansion. Second method, it's similar, but we don't have to do the long division. We have 2x squared plus 5x minus 6 divided by 2x minus 1 times 1 plus x. So we know that we need to express two fractions. One is 2x minus 1. The other one is going to be 1 plus x. And the numerator has to be x squared. And it can't be with just a factor, with just a number here. So what I'm going to do is I'm going to include an x factor in the numerator of one of the two fractions. It doesn't matter which one. Okay, so this one is going to be ax plus 1, as if it were an imaginary root, but it's not in this case. Okay, so ax plus b times 1 plus x plus c times 2x minus 1 equals 2x squared plus 5x minus 6. So that means ax plus ax squared plus b plus bx plus 2cx minus 2 equals 2x squared plus 5x minus 6. And now I'm going to equate terms. So there's only one in ax squared. So that means that a equals 2. Then in x we have b plus 2c equals 5. Sorry, a plus b plus 2c equals 5. And as a was 2, we know b plus 2c equals 5 minus 2 equals 3. And without an x, we have b let's see here. So that b minus c, we have b minus c equals minus 6. So if I subtract these two equations, b minus b is 0, 2c plus c is minus minus, so it's plus, it's 3c, 3 plus 6 is 9, so c equals 3. If c equals 3 and a equals 2, we can go to either one of these equations, and we have b equals 3 minus 2c, which is 6, so b equals minus 3. And so our partial fractions expansion is going to be ax plus b, so that's 2x minus 3 divided by 2x minus 1 plus 3 divided by 1 plus x, which is already a partial fraction expansion, but if we want it simplified, we can add the division of 2x minus 1. 2x minus 3 divided by 2x minus 1. So we have a 1 here, and that's 2x minus 1. Minus 3 plus 1 is minus 2. And so my original fraction, I'll write it in red now, 2x plus 5x minus 6 divided by 2x minus 1, 1 plus x is going to be 1 minus 2, which is a remainder of 2 divided by 2x minus 1, and then let's see here, which was 3 plus 3 divided into 1x plus 1, which is the same as before, and we get the same solution. We don't have to do a big long division, but then we have to do the other one, because this will already give us, this will give us a fraction which is not the most simplified one. So this is not one of the methods I prefer, but it's another method. The third method that I can give you, and this one is really an alternative method to this one, is that we know that when the numerator is going to be the same as the denominator, there's going to be a real part. So what we can do is we can express this as a partial fraction expansion with a part that's going to be a whole number. Okay, as we saw, that's going to happen. And as we know that that's going to happen, we can express it already like that. And the good thing is that the partial fraction expansion will already give us what we need. You'll see. If we do this, that's going to be a times 2x minus 1 times 1 plus x plus b times 1 plus x plus c times 2x minus 1 is going to be 2x squared plus 5x minus 6. So now what we can do is we have that the root here is minus 1. We have the root here is minus 1 and the root here is a half. So if we introduce the roots in these factors, we can see that if we introduce, for example, minus 1, this one goes away and this one goes away because those factors are 0. So we can have c times minus 2 minus 1 equals minus 1 squared is 1, so 2 minus 1 times I is minus 5 minus 6. So minus 3 c equals 3. Well, we can multiply these ones to obtain that to find the factor in x squared. So the only factor in x squared is going to be 2ax squared. So that has to be equal to 2x squared. So a equals 1. And with those two, we can now introduce the factor of a half. So we see that the factor of a half is going to be this one, and this one goes away. So we have b times 3 halves equals 2 quarters plus 5 halves minus 6. So 3b halves equals 2 quarters plus 10 quarters minus 24 quarters. So that's going to be 12 quarters minus 24 quarters, which is minus 12 quarters. And so b equals minus 12 quarters multiplied by 2 divided by 3. That's a 4. And that's b equals minus 2. And so we get the same expansion that we had before, 2x squared plus 5x minus 6 divided by 2x minus 1, 1 plus x equals a, which is the real part, plus b, which is minus 2, divided by 2x minus 1, plus 3 divided by 1 plus x, which of course is the same as the two expansions that we had before. So if we need to expand, if we need to do the partial fractions when the numerator equals to the denominator, rule of thumb is to do the long division. Another method would be just to create these partial fractions and then do a long division, short long division here. And the other also fast method is to remember that this will always give us a real part, so we can do the partial fractions with the real part and the two other fractions.